Hello, this is the simple code which is used for blinking in LED on Raspberry Pi. So what we are using is the Raspberry Pi GPIO library specifically defined for Python. So the first line, if you see here, we are importing that library as a GPIO, and then the second library, import what we are doing is basically from time, where we have used sleep. So this basically is used for bringing in the required delay. So below that, if you see, the first thing is we are just setting up any warnings that come out to false, so we can comment it, and then the second thing is the major one, where as designers we know that the pinout basically which we are considering is from the processor or the microcontroller. Here if we talk about Raspberry Pi, it's the BCM processor. So the pins that are extracted out of that processor would extend to the connector, the 40 pin connector. Now Raspberry Pi libraries which are written help us in two ways actually. So you can use the actual pin numbering by defining GPIO set mode as GPIO.bcm. So for example, if you are pulling out a 18th pin on the processor as a GPIO, so you have to define the pin name exactly as 18. But to make things convenience, on the Raspberry Pi we know that we have a 40 pin header to which different pins are pulled out. So these are basically called the physical pin numbers, where we have 1 to 40 for this connector. So you can use that numbering instead of the actual mapping that is happening from the processor, the actual pins that are pulled out from the processor. So that's the kind of convenience this library brings in, and if you have already worked on microcontrollers or processors, you can feel how easy it is. You need not even search for the actual pin that is coming in and configure. So you can either use the actual pins if you are convenient with that, or you can use the set mode to board, where the board defines the physical pins on the connector 1 to 40. So we set mode to board now, and then we'll be setting up the GPIO next. So setup is the function that is used here, and the number, the physical number on the connector is 8, which is set to GPIO out, and then initially it is set to low. So this function defines the pin to be, selects the number, defines the pin, and then state of the pin is defined. Now there is a control continuous loop which is set up while true, and we are setting the GPIO 8 to GPIO high, and then with a delay using that sleep method. So here if you see, we are actually connecting. This is the schematic of the Raspberry Pi, the 40 pin connector with the 0.1 inch width, the spacing between the pins, the connector pin spacing basically. So here we have used the 8th pin. It's actually GPIO 14 on the processor, but physically it is 8 on this specific J8 connector. So we have used 8 here. So by running this simple program and using the instructions, next we see that the LED blinks on Raspberry Pi. So very simple to use. Only thing what you need to know is basically get to know the functions that are defined in the library and just pull them out, configure as per your requirement, and run the program. One more important point is that just ensure that you connect an LED on the breadboard, which we show in the next video, where the LED is blinking, and also appropriate resistor is selected such that LED doesn't blow out. A simple breadboard connection or a connection in the external just outside air also would work by tying up an LED to wires. Please post any comments on this. Please suggest any improvements which we can make. Thank you. So to explain the circuit, you see a resistor here, series resistor for current limiting to the LED. You cannot connect the output voltage that comes out the GPIO to LED directly. It might rush in more current and the LED gets damaged. So current limiting resistor is always necessary. And then you can see here the LED anode is connected to the one end of the resistor and the other end to the ground. So these connections, if you see, are going to a 40 pin connector. So this was the 40 pin which we were talking in the schematic, and you can see here the physical pinout is from 1 to 40 here, and then we used pin number 8 for the GPIO, and then the adjacent ground pin. So very simple connection, so if you are familiar with the breadboard connections, this is also a very simple circuitry which can be used for your experimentation.